Hi, and welcome to another episode of Red Talks. I have a very different guest with me this week, Shawn Wormke from Aspen. Shawn, say hello.
Hello, everybody.
So, Shawn, first, okay, little bit of background. Why do I know you? Tell us, how did you come into the same world as us on Red Talk Studio? Where did you get involved with the same line of business?
Yeah, so Aspen Mesh is actually an incubation project and an innovation project within F5. And so I'm actually an F5 employee, but we're working on a new project that needs a little bit of space to breathe, if you will, outside of the traditional corporate structure. And so we've started this incubation process internally, and I run one of those called Aspen Mesh. So that's how we came to know each other. We've actually known each other for quite some time, but in probably a little bit different capacity these days.
Yeah. Now, so this incubator thing's like, I understand the concept. It's a really cool idea, and I want to make sure that kind of resonates with our listeners. I mean, you're effectively almost an independent company, but not. How does it work?
So there's a number of companies doing this today as you look at how you explore new technologies that may be not part of your core. So some companies call it intrapreneurship instead of entrepreneurship. It's a way of basically making an investment, much like you would as a venture capitalist or anything like that, and allowing a team some autonomy to go discover a new space that you don't currently play in. And so when you look at very large companies like F5 or these very large enterprise companies, they're set up to run the traditional business very, very well. They're very efficient at it. They have lots of processes and tools and business models and things that they've been using for years. And in F5's case, almost 2 decades now, they've been iterating on their business model and refining it to make it this machine that's really good at selling their core set of projects or products. So when you come up with a new idea in a new space that doesn't look like the old product, the old processes and business models may not apply to the new thing. And trying to get the attention and the kind of priority that you need to get new businesses started and underway in an enterprise company is traditionally very hard. So, it's pretty hard to go to a sales team and say, I really want you to sell my product. And they look at it and they say, it doesn't do anything. And you're like, no, it does these 2 things. And it's really awesome, isn't it? And they're like, well, how much money am I going to make? And you're like, well, we're not sure. So this is a way to kind of carve out some time and resources and give the teams that have come up with these ideas the autonomy to go see if there's something there, right? So to start a little bit of engineering work, a little bit of business model evaluation, and really allow them to work outside of the norms with the support of the full company behind them.
That is the best description I've heard. I mean, I obviously knew about the whole incubator thing internally, but that was a really good way of explaining it. And while I was listening to you say all of that, there was just one word that kept coming to my mind, which was that the idea and what you're executing on is protected. It can't accidentally just get consumed or reprioritized or whatever. And to me, that just shows commitment to that execution. If you're going to put that effort in to resource it and to put it and isolate it into this incubator, that's just a greater commitment to execute and to get something out at the end of it. So that's kind of cool. If something makes it into an incubator, I mean, that's a big deal. That's not, you know what, take 3 guys for the next 2 quarters and see if you can come up with some crazy Frankenstein POC. I mean, this is more commitment than that.
Yeah, absolutely. So one of the interesting things here is that, when you start to go down this incubator path, it's not like we're just, like you said, off doing some skunk works with 2 guys for a quarter. We have
like the stuff that I do.
Yeah, exactly. It's not like some guy on YouTube having the REDtalks.live. No, this is I'm funded, like I said, venture capital wise. We have milestones that we are held accountable for, and we're working towards those milestones. And those milestones, depending on where you are in your incubation and what type of incubation it is, those milestones for us are based on customer conversations, customer acquisition, business model development, and things like that at this early stage, because we are really early. So I always tell people, treat us like an A-round startup. Right now we're a very small team out here in Colorado, And our milestones are very similar to an A round startup, where you're trying to define market and product fit as you move through the next 12 to 18 months of this project. And once we get there, we'll look at, we should be proving that, hey, there is a market here and there's a way that we can do business and make money. And if not, then just like any other startup, we don't get our next round of funding. So it's a little bit different than the traditional.
That's interesting. So not only is it a big commitment to execute, but you have to execute.
You have to execute. Yeah, execution is key, right? I mean, that's one of the reasons that, and actually, the autonomy and the support from the company makes that a lot easier, but it also makes you a lot more visible as far as, the execution is generally your fault if it doesn't work out, or the market's fault or whatever. But you don't get to kind of say, oh, well, it took 6 months to get a sponsorship for something from this group. It's, you have that ability to affect the outcome much more rapidly than you had before.
Now, you're not a total stranger to startup world, are you, Shawn?
No, I came to F5 as a startup employee. I worked for Line Rate Systems here in Colorado, and F5 acquired us in 2013. And so I was an early employee at Line Rate. I was employee 4. So this isn't new to me. Maybe the role that I'm playing now is a little bit different than what I've played in the past. But yeah, it's definitely something I'm accustomed to.
That's good to know you're an experienced hand at this. So we've covered, I think, more than enough about what's this incubation process and what is it that you've been entrusted to do and how that's protected your expectations to execute. You're not protected from failing, but let's talk about what it is that you're producing. So Aspen Mesh, first, where'd you get the name from?
Okay, so that's a really that's actually a great question. So an aspen tree is one of the world's largest living organisms, and when we talk about what a mesh is, I think you'll see why this applies. But basically, all the aspen trees are in a clump, are connected together by their roots, and they spring up new trees all over the place. And so when we look at how containers and microservices kind of connect together, it reminded of us of this kind of connected aspen tree thing. And the genesis of this was based on a product at F5 that we worked on for a few years called ASP. And so we tried to give a throwback to that name and call it Aspen, ASPEN. So, and Aspen's a very Colorado type of a thing. So that's where the name came from.
That's cool. I thought it might have been some ski trip and someone went, hey, that's a nice tree, but there's actually a much better story than my imagination gave me. It's actually really cool because it's relevant. Like you said, I mean, when you see an aspen tree, what we see above the ground seems to be a single isolated tree, but actually that's not how they grow. It's a community of trees, and they grow together and keep taking more and more space. And there's awareness of each other as well. So it's actually a really good metaphor for kind of what you're working on. So moving past trees, the technology side, I mean, you talked a bit about a common sort of architecture now where we have microservices and you're not managing individual instances of a virtual machine. And if something goes wrong with the virtual machine, you might reboot it or reclone from a template and repurpose another one to replace the failed one. But it was still that operational kind of process of I'm managing virtual or physical instances of things. Whereas when you go into more microservices, I mean, it's very ephemeral. They're architected around being intentionally volatile is the term I try and use a lot when I talk about microservices, whereby it might not just even be a failure where a service is terminated. It might just have done its job, and why leave it running? Because they are designed to very quickly exist and then fill their purpose and then not exist anymore. So how do you architect a system that's traditionally manually operated around this ephemeral, like intentionally volatile architecture? And that's the solution you're kind of creating, isn't it? Is to address that. Is that right?
Yeah. So basically what happens when you get into this world of microservices is it gives your development teams this sense of autonomy where these small teams can build, run, and deploy their services at will, and they can start to make choices around what they're deploying and how, and what types of programming languages, for example, they're using and things like that. But when they do that, it becomes very complex because no longer do you have this monolithic application that you're trying to manage and deploy. You now have, tens or hundreds or even thousands of these little things sprinkled all over the place. So in order to get an idea of what they're doing, how they're doing it, who they can talk to, who they can't talk to, and things like that, you need something in the middle that's managing that communication. And that something in the middle has been be known over the last year as a service mesh. And so Aspen Mesh is a service mesh technology that we build on an open source project called Istio, which has a proxy inside of it called Envoy. And so Aspen Mesh is bringing enterprise service mesh to our customers, our F5 customers, and beyond.
So with an implementation of a service mesh, I guess the shift that happens, and we talk a lot about this in DevOps and the kind of super NetOps, the evolved NetOps engineer addressing a system. And often when I talk to people about this, I refer to the evolution of like the automotive industry. Like a lot of automotive factories today, they have robotics, but the robotics are just there to support people, and they still move at the pace of people. There's some efficiencies that were gained, but they're still ticking along. This person is moving the windshield that a robot put in place, attaching it to the car. And then you've got the flip side of that, which is Elon's wonderful Tesla factory, where actually people support the robots. And the system is just going and running and processing all the time. And I guess when you're going to work with these very ephemeral environments with microservices, you can't sit there and be provisioning IP addresses and connecting the services together. That just does not happen. The system fails. So a service mesh is, I guess you're creating a system that itself, once configured, can address the needs around it without being human, without the protein army being inside that process, inside every change that's going on. Is that a good description of a service?
Yeah, absolutely. So, one of the things that a service mesh, one of the goals of a service mesh is to allow developers and the teams writing their services, these ephemeral services that come and go, to just focus on their code and their application and give them kind of the infrastructure underneath that lets the machines manage what's going on. So what it allows you to do is not worry so much about the type of logging and tracing infrastructure you have underneath. It kind of takes care of that for you. It allows you to automate policies and really get an understanding of how things are talking, for example. So instead of having to know where every one of your other services are, the service mesh takes care of that for you. It helps route things to different places. A human, like you said, doesn't have to know what's going on anymore. The service mesh can figure out the health of the services that are surrounding it, for example, and redirect things based on some criteria that you've given it. So, I mean, a lot of these concepts are not new to network administrators or application DevOps types of people. They've just moved to a different place. So we still do proxying, we still do load balancing, we still do health monitoring, but the way we do them and how they do them and the things that are important inside of these newer environments are different than they were in a traditional three-tiered monolithic type of an architecture. So, less people, more automation, more visibility. But along with that, one of the things that Aspen Mesh is working on is how we look at application behavior and allow, because at the end of the day, humans still have to fix the problems if there are them, but how do we let the humans understand what's happening and what happened in the past as well? Because if the ephemeral container's gone and there was a problem, you'd have nothing left to debug. Most of the time, you don't even have access to the thing to debug. So Aspen Mesh's kind of goal is taking this concept of service mesh and really allowing people to have the visibility, analytics, security, and policy from an application-centric point of view to help them manage that whole complex system underneath.
That's really cool. And when we talk about less people being involved in every process, we're not going Terminator 3, Rise of the Machines. You don't need a job because the robots are killing us all. We're not there. That's not the target. But if I understand what you're saying correctly, it's more a case of the operator of the mesh, the administrator of this, is working out what the policy should be, and not every single point in which the policy should be enforced. That is the system taking care of that, because the system itself, once configured and implemented, understands, okay, 7 more instances of that microservice just got deployed. They're all a new version that wasn't running 10 minutes ago because a new code commit just came through. So I know with this version, I have a new policy definition that they've been working on, and I'm putting that one in front of the new system. So it's more about that, so that the people with the domain knowledge about what the policy should do are just defining the policies, not its individual implementations. Did I get that right?
Absolutely right. So it actually allows you to let that policy be defined by the people who know the most about what that policy should be, and in the right places in the application stack, if you will, right? So, you know, one of the huge benefits for the mesh is that you can have a single place in the network, the service-to-service communication. You have a single place to apply that policy and enforce it. And that could be a security policy, or it could be an SLA type policy. It could be, you know, we talk about policy, my mind automatically goes to security, but it's not just security, right? It's about maybe I need a certain amount of uptime, or I need to have certain latency requirements and things like that for my services. So you can start to deploy and inject those things inside of the mesh in this single place. And then the people who are writing the individual services or applications inside of there, they don't really need to worry about it nearly as much as they have to in an older type of, without a service mesh. Without a service mesh, each application has to individually implement and understand all of that. But with the service mesh and this point at which you have a little bit more control over what's going on from that service, you can attach those policies and make those decisions more efficiently, really, is what it boils down.
To stick to the security example that you just gave, anyone who's worked in like network operations, if you, let's say someone finds a vulnerability in a specific cipher that you know you're using in lots of places, so you need to now go to all of your, this is in a traditional architecture, all of the implementations of that cipher, and you've got to manually go through. Now, working out the change that need to be made ends up being maybe 5% of that job, and the other 95% is scheduling the outage time that I can go through, and I can make all these changes, and that ends up being weeks and weeks worth of work.
Yep.
Whereas what you've eliminated with this service mesh kind of concept is actually, I'm just going to update the policy, and I'm no longer responsible for manually doing the implementation of that. This is the new policy moving forward, and you're not stuck like you were in the 3-tier kind of traditional static architecture, where you need to have a change management window at 1 a.m. on a Sunday night to now roll that policy out. I mean, you don't have that problem anymore, do you?
That's right. Yeah, absolutely. So one of the, since I don't want to go too much into the details, but basically you deploy a proxy next to every one of your applications. And so what that allows you to do is control the way that those two services communicate with one another. And so, by, just like you said, when you have a vulnerability or you have something, you can deploy a new version of that sidecar, of that proxy, and across your entire mesh, and you've taken care of it all in one fell swoop. You no longer have to go chase down people all over the place who are writing these services and say, hey, you have to change, and you have to make sure that you have OpenSSL version, whatever is your new standard that they have to go implement in their containers and then even in their VMs or their OS or whatever they're running. Now, since you talk, from container into the proxy that's attached to it basically by a sidecar, the container can have a little bit more freedom over what's going on, because the sidecar now controls that communication that happens and can ensure that you have the SSL stack that you need there. But the same can be said actually for continuous deployment and continuous integration, because one of the things that the sidecar allows you to do is, just like you said, since it understands the topology and what's going on, you can start to eliminate even some of the test and integration setups that you have and start to deploy directly into prod. And that sounds a little bit scary, but what you can start to do are these canary and blue-green deployments where you can say, I want to deploy version 2 of my service, and I want to put 1% of the traffic over to it. And I want to test and see how that behaves for that 1% of the traffic. And then I want to move 5% over. So you can continually move over percentages onto your new version until you're sure that nothing's wrong. And then you can take the old version away without really affecting anything, which is a very powerful thing for development.
with that model you just described, when you're going into the full deployment 100%, you are far more confident of the success of that, because that 1% of test is a tiny impact. You were already confident it was going to work, but you've tested it on a small environment that you could watch and be sure, now I know what's going to happen, versus that jump from test to prod 100% and being like, oh, okay, got it. I just inflicted 100% of my user base on that. So yeah, going straight to prod, totally. I mean, it's not scary, actually, doing it the right way, in the right controlled kind of manner.
Right. And then the thing that, when we look at Aspen Mesh, the product, I mean, that service mesh gives you that kind of ability out of the box, right? So when you look at Aspen Mesh in general, since we have been able to watch and understand your applications over time, we can actually start to look at, here are the impacts of that 1% of the traffic and how it compared to the traffic that we've been watching for the last 3 days, 3 weeks, 3 months, 3 years of your traffic. Well, not 3 years, I haven't been around that long. But we can start to watch, and say, hey, your new thing is better or worse, for some definition of better or worse, and help you actually make those decisions. Latency has gone up, or you're seeing more errors or less errors and things like that as you start to roll this out. So that's where we think that we provide a lot of extra value on top of the open source deployment, is this notion of predictive analytics that we're toying around with, and that's what you get when you buy the Aspen Mesh from F5.
That's cool. Now, I imagine a lot of people are wondering, like, okay, you don't have just one app. We're not all like, Google, Facebook, Twitter, the big ones out there where you actually can have a common policy. I mean, most people are going to have very different apps and policies running concurrently. So yeah. I take it you're going to use a lot of like metadata tagging and service discovery and service advertising engines. That's how you kind of get around those type things, right?
Yeah, so what the plan, this is a very nascent technology in a very nascent space, but what we're starting to see is that policy and the definition of that policy is becoming very, very important. And along with that comes the fact that you don't really want an experience for your users that's different than the native experience that they're using, right? So if they're using Kubernetes, you want to look and feel like Kubernetes. You don't want it to feel like some crazy different thing. So yeah, the idea is that through tagging, through service discovery, and a little bit of the way that you kind of write these policies that are attached to the service mesh itself, you get this notion of, if you belong to this bucket, you get this policy. If you belong to this bucket, you get a different policy. So that is the goal. It's not not everyone's a Google or a Twitter or a Facebook, and they're not going to be able to do that. So again, part of that is us helping people understand what policies are deployed, what impacts those policies are having, how well they're working for their users, and then making adjustments, and also helping them kind of roll up some of these individual policies into a group or a catalog of things. If you want to, for example, do mutual authentication between your applications, you deploy this policy, and Aspen Mesh will take kind of all of the open source policies that make that happen and roll it up into a single policy that you can deploy as a catalog type situation.
That's cool. And I like that last example, identity and like mutual authentication, those kind of things. We talk about often security and it's just, oh, a firewall or this, but what about actually services, providing them across different microservices, et cetera, and services might be authentication, identity, or federation, et cetera. Like there's more than just load balancing firewalling going out there from you guys.
Yes. Yeah, and I think too, with the container space in general is very new, and some of those new security requirements haven't yet been defined. But being able to say, yes, this is the service that I think that it is before I talk to it, and keeping your containers or the services and the containers that make them up only talking to the things that they're supposed to is kind of that leading edge of where these types of spaces are moving. As more and more people move to production, as more and more, less and less of the Googles and Twitters, and more of the financials, the insurance companies, and these larger enterprise start to deploy, the security requirements around those things are just starting to kind of come out and flesh out. This whole space, like I said, is very new, but as people, larger and larger enterprises start to deploy this, we're going to see I think a much different landscape than we have today in the next 3 to 5 years.
Well, I imagine the just ship it squirrel would be very, very improvable of this. Anyone in the dev space will be very familiar with the just ship it squirrel. So I won't take any more of your time. I just wanted to, like, I really appreciate you talking with us today and giving us this insight into kind of where you're going, what you're trying to address. It would be great if this was just a part one, and we could catch up sort of iterations in the future and just talk a bit more about, what are you discovering, what were interesting challenges that you needed to solve, and even just the process you're going through. You're starting a company effectively.
Yeah.
And what did you look at today versus maybe how you would have done it 4 or 5 years ago in the previous startup? Like what's the evolution of tooling and what were you able to solve? So I mean, I'd love to have you on again in the future, Shawn, if you'd entertain us.
Of course, I'll entertain you. It's hopefully, hopefully you'll have me back. I'm not my first actual video interview like this, so hopefully we did a good job and you can have us back.
Clearly a natural, Shawn. So thanks for coming along. You guys have been listening to another episode of REDtalks.live. Shawn, have a great day.
All right, see you guys. Thank you.
Awesome. You've been listening to Nathan Pierce and Shawn Wormke. Thanks for listening.